Okay, the nice thing about what we're going to talk about today, if you'll open to page 203, you're going to notice there's an essential question there at the top. Page 203, open it up. It's actually the beginning of 7.1. We're starting a brand new module. The nice thing about this module is it's very similar to the module that we did before, where we were writing and solving equations. Now we're going to talk about how to write and solve inequalities. What do you suppose the difference is between an equation and an inequality?
It's not equal. It's not, yeah.
It's not equal. Which, if it's not equal, what symbols would we use?
Equal sign. Or no.
Trevor? Okay, we could use a not equal sign. What else could we use? Graham? Pardon? Greater sign or less than. It can be greater than or equal to, less than or equal to, greater than or less than. That's what we're going to talk about. And how to write and solve those one-step inequalities. We spent 2 or 3 days working on one-step equations. We're going to spend 2 days working on one-step inequations or inequalities. You'll also notice in the corner, that's the Florida Standard. It really is the learning objective for this particular section. It really says students will be able to use variables. A variable is what? It's an unknown number. That's really what it is. To represent quantities in the real world or a mathematical problem, construct, what does it say? Simple. Please notice that word, simple. Doesn't have to be hard to be able to construct it. Talking about things that are easy to work with. Simple inequalities to solve problems by reasoning about those quantities. Now, most of your notes today, you shouldn't need a sheet of paper for. We should be able to do right on this packet. So we're on that same page, page 203. We're going to fill in these two tables that are here. Notice, in the first table, they asked me to add a number to both sides of the inequality. So, they're asking me to add 3 to both sides. If I rewrote that, what's 2 plus 3? 5. Is greater than or equal to, what's 3 plus a negative 3? 0. Notice it started out with a true statement. 2 is greater than or equal to a negative 3. This was true. Is 5 greater than or equal to 0?
Greater.
Right, it is greater than, so this would also be a true statement. Everybody see what we're doing in the table? We're filling in the blanks. Right? If I add a negative 1 to both sides, what's a negative 1 plus a negative 1? Negative 1 plus a negative 1. Negative 2. They both have the same sign, so I'd add them. And 6 plus a negative 1? 5. Again, it started out with a true statement. Negative 1 is certainly less than or equal to 6. Is negative 2 less than or equal to 5? It's less than, so it is less than or equal to. This is also what? True. I'm adding a negative 8 to both sides. What's a negative 8 plus a negative 8? Negative 16. And a negative 8 plus a negative 10.
Negative 2. Negative 18.
They both are negative, so I'm going to add them together. Negative 8 was certainly greater than a negative 10. Negative 16 greater than a negative 18?
No. Yes.
Yes, it is.
Closer to 0.
Would you rather owe somebody 16 or owe somebody 18? 16. So it's definitely still a true statement, isn't it? Okay. Everybody with me so far?
Yeah.
What you should notice is that if I add something to both sides of the inequality, that it doesn't change the inequality is still what? True. If I started out with a true inequality, if I add the same thing to both sides, just like I did in the equation, I'm not changing the inequality in it. It still is going to have a true value.
What has two negatives, like start with the first one?
What do you mean? Here?
How do you know if which one to start with?
What do you mean?
With it's like the same two negatives, same sign.
If they have the same sign, you keep their signs and you just add them. What's 8 plus 8? 16. What's 10 plus 8? 18. They were both negatives. So I just add them together and I keep their sign. Okay? Everybody with me so far? Okay. I can live with that. Okay? Let's look at the table that's at the bottom. The only thing that's different is going to show up in this table. The only thing that we're going to do different today than we did over the last week or two shows up in this table. Notice, again, they're asking me to divide both sides. What would happen if I divided 4 by 4? What would it give me? 1. What's 8 divided by 4? 2. Again, if I look at my original inequality, 4 is certainly less than 8. That's true. Is 1 less than 2?
Yes.
That's still true. So it appears that if I divide both sides by the same thing, that I'm still all right. Correct? That's what it looks like. If I divide both of these by 3, what's 12 divided by 3?
4.
This is greater than or equal to negative 15 divided by 3
Negative 5.
is 4 greater than or equal to a negative 5.
It's greater than.
So it is greater than or equal to, it is true. Now take a look at the next one. It says a negative 16 is less than or equal to 12, which is obviously a true statement. What would I get when I divided a negative 16 by a negative 4?
A positive.
A positive 4. And what would happen if I took 12 and divided it by a negative 4?
You get a negative 3.
This would say 4 is less than or equal to a negative 3. Is that true or false?
False.
That's not true anymore, is it?
No.
So notice, when I divided by positives in either case, it was true, but when I divide by a negative, it came up as what? False. Okay. Let's see if it does it the same way on the next one. 15 divided by a negative 5.
3.
What kind of 3? Greater than? 5 divided by a negative 5.
Negative 1.
Is negative 3 greater than a negative 1?
No.
That's also false. What could I do in the bottom two statements to change this inequality so instead of being false, it would be true?
Get rid of the negative sign.
I want to change the inequality, though not change the numbers. You're right, if I got rid of the negatives, it would work.
We could add negatives.
What could I do to change the inequality? The only thing I want to change is this part. What could I do to change it to make it true? No, I don't want to change the numbers. I don't want to change the number. No.
So turn the greater than sign around.
Turn the greater sign around. Flip it. Reverse this. If this said 4 is greater than or equal to a negative 3, that would be a true statement. If this said a negative 3 is less than a negative 1, that would be a true statement. The only thing different between equation and an inequality comes when you're multiplying or dividing by a negative number. When you multiply or divide by a negative number, what are you going to have to do to that inequality symbol? Switch it. Flip it around. Okay? So, on the bottom of the next page, actually it's on page 205.
Wait, we put flip it for number 1 on the plate.
Yeah, you're going to have to flip it. When you're dividing or multiplying by a what? By a negative.
Negative.
Let's take a look at number 4. Before I learn how to graph these, I have to know the difference between what an open circle means and what a closed circle means on a graph. If I use greater than or equal to or less than or equal to, this circle would be closed or filled in. If I use greater than or less than, these circles would be open or not filled in. And here's why. These say it can be equal to it. In other words, if I say 5 is less than or equal to 5, that would still be true because 5 equals what? I could touch the 5 and still be true. That's just the way I wrote them. That's just the way I wrote them. They typically draw it what? Straight underneath. Okay? It's just the way I write them. You need to know that if it can be equal, that it has to be a closed. In other words, it can get all the way to that point. If it doesn't have an equals piece underneath it, it's like putting a force field around that particular number. I can get really close to it, but I can't quite what? Touch it. Can't be there. So I can get as close as possible without what? Without touching it. So that's why this is going to be an open circle. Let's look at this first problem and determine open or closed. Closed. Let's look at the second one. Open or closed? Open. Now, both of these are there. You want to make sure you're taking some notes on them. I've written a couple things down already. I see people that haven't written them. If I take time to write it on the board, you should be putting it where? On your paper. Okay. The rule is the same. When I'm solving an inequality, I want to get the variable by itself. If I want to get this y by itself, how would I get rid of subtracting 5? What's the opposite of subtraction? It's going to leave me y is greater than or equal to, what's a negative 7 plus 5? Negative 2. I'm going to put in a closed circle on the negative 2. And if I want my number to get greater, which way do I go? To the left or to the right? I go to the right. If you ever want to check to see if you've gone the right way, it's really easy to check. Pick a number that's on your line. I'm going to pick 0 because 0 is an easy number to work with. What's 0 minus 5? What's 0 minus 5? Negative 5. Is negative 5 greater than a negative 7? Yeah, so it would be true. I'm going the right way. Okay? And number 5. I want to get what by itself?
Variable.
How would I get rid of the 12? I've got to subtract it from both sides. When I do that, it's going to say 9 is greater than or greater than x. So the first thing I'm going to do is find 9, and I'm going to put an open circle on it. Then I'm going to determine which way I'm going to go. We want to be careful. The left is the right way. Notice that the variable is on the other side of the inequality this time. I always look to see, is the point towards the variable, or is the open end towards the variable? The point, the smaller end, is towards the variable. It means x is getting smaller than what? 9. So it must go to the left. Any difference dealing with the addition? Same as the inequality, except we can now graph it, right? But we do the same process. We either add or subtract the same thing from both sides. No difference. Are you okay with this screen? Good? Can I go?
Yeah.
Okay? Yeah.
You're recording it right now?
It's recording this class, yes.
Or is it just audio?
It's just this class?
It's audio and the video of this, but it doesn't see people.
Is it just this class?
Recording right now.
Can you hear me? Can you hear me?
It's just taking away from time that you could be working, guys.
Can we get extra credit for
Okay. I want to talk not so much about the addition and subtraction properties of inequality. By the way, these were written in your notes. They're there. You don't have to copy them down. Okay? They are there. But I do want to talk about the one that says multiplication and division on the bottom of page 205. Notice it says you can multiply or divide both sides of the inequality by the same positive number, and the inequality will remain the same. True. Okay? If I multiply or divide by a negative, and I take the time to underline that word, negative, on page 205, the word negative, I'd underline it. And if I multiply or divide by a negative, what do I have to do? Reverse the inequality, and I'd circle that. The only rule change from today dealing with inequalities versus equalities is the fact that if I multiply or divide by a negative, I have to flip that inequality symbol. Only difference. Are you okay?
Yeah.
Good? Now, this you don't have to write down. You're going to find this on page 206. Notice they have y divided by 3 is greater than or equal to 5. Would this make an open or a closed graph?
Oh, close.
Closed, because it could be equal. It would be closed.
Oh. It's page 206.
Page 206. It's there at the top. They've already worked it out. If I wanted to get y by itself, what would I have to do? It's being divided. I would have to
Multiply by 3.
Okay. When I multiply both sides by 3, these 3's would cancel out, leaving me y is greater than or equal to 15. Notice I did not flip the inequality because I'm multiplying or dividing by a positive number. So when I graph it, my graph should look like that. A closed circle on the 15, and it would be going to the right because it's getting bigger. Okay? Now, for 6 and 7, which are there at the bottom of the page, again, make sure that what I'm doing up here, you're doing on your notes, On number 6, what would I have to do to get the variable by itself? Divide by a, what kind of 10?
Negative. Positive. Negative. Negative.
If I divide both sides by a negative 10, what do I have to do to this inequality symbol?
Make it negative. Oh.
What do I do to the inequality?
Close
I do what with it?
Flip it.
I flip it. It is going to be open, but I do have to flip it. This is going to be y. And when I take 60 and divide it by a negative 10, it's going to give me what kind of 6?
-6.
It's going to be an open circle on negative 6.
So you always have to flip it.
If I'm dividing or multiplying by a negative, what do I have to do to that symbol? That's the only time I have to flip it, is if I multiply or divide by a negative.
We put those on a quiz for test.
Oh, yes. Yes. I mean, as far as that kind of question, yes. The rule? No.
About the flipping.
You need to know the rule.
Okay.
Okay?
On your quiz, we have the number line, we gotta have it open and close.
Yes. You'll have to graph them. Okay? So, this says y is getting bigger than a negative 6. Which way would I have to go? Left or right?
Left. Right.
I'm getting bigger.
Oh, right.
Y is getting greater than a negative 6. Okay, still an awful lot of noise, and I'm tired of talking over you. I'll start removing people here shortly. What am I going to have to do in number 7?
You have to multiply.
Jewel? Okay, I am going to have to flip it. What am I going to multiply by? What kind of 6? If I multiplied by a positive 6, would I have to flip it? No. Only if I multiply or divide by a negative.
Oh my gosh, this is confusing.
I multiply both sides by a negative 6. This is going to give me a negative 42. What am I going to do to that symbol? Flip it. Less than or equal to t. Open or close circle on the negative 42. Closed. Again, be careful, you're reading it from the side that the variable is on. It says t is on the larger side of the negative 42. Which way do my numbers get bigger, the left or the right? They get bigger on the right. So, if you want to talk about the open and closed circle being different than what we did, you do need to know that if it has more in the symbol, in other words, it has that extra line, it has more, that you got to put more in your graph. You've got to fill in the dot. Because it can be equal to it. If it has less, then you put less in your graph. It's going to not be filled in. Because it can't be equal. It's like having a force field around it. You can get close to it, but not be it. Okay? Okay? The other thing that's different has nothing to do with addition and subtraction. It has nothing to do with multiplication and division by a positive. It only deals if you're multiplying or dividing by a negative. If you multiply or divide by a negative, you have to reverse or flip that inequality symbol. Everything else that we've done for the last 2 weeks is exactly the same. I want to get what by itself? The variable. That did not change. I can add and subtract to both sides. I can multiply and divide to both sides. But if I multiply and divide by a negative, I have to flip or reverse that inequality. Only difference. Everybody good? Grant. Are you sure? There's your assignment. 208 and 209, 1 through 18. They won't take long. Okay? You should finish them in class.